Hey all, so we're going to look at a new type of proof. This will be in comparison to direct proof that we've been spending the last little lessons on. So get yourself ready for notes, and now we are going to talk about contrapositive proofs for the next couple of days before you go into your Thanksgiving break. So first thing I want to do is talk about what contrapositive means. So if we start with a regular statement, so just something like if X, then Y. This is a regular logical statement that we've seen before. We might even write it as X implies Y. And here we have the hypothesis and the conclusion. Now for direct proof, we just go, okay, assume the conclusion is true. How can that lead us to the hypothesis? Assume the hypothesis is true. How can that lead us to the conclusion? Now, the contrapositive is basically the opposite. And the idea is that if Y isn't true, then the hypothesis X can't be true. So the idea here is if the conclusion is false or is not happening, then the hypothesis also has to be false. And this method can be really helpful, and I'll show you what that means in a minute, but the idea is that if this is true, these two can both be true at the same time. Now there's other ones like if the conclusion, if the conclusion is false, that proves the hypothesis, but if the hypothesis is false, that doesn't necessarily prove the conclusion is false, and so on. These are the only two in which the order is always a proof method. So let's talk about when to use contrapositive versus direct. So if I'm looking at number 1 here, suppose X is in the integers. If 7X plus 9 is even, then X is odd. So if we took the direct proof method, then we'd start with, okay, say 7X plus 9 is even, and then we'd start just like we would maybe last week, say that that's equal to 2A. Okay, well, we want to get X by itself, and so then we start subtracting and dividing, which division, remember, is not closed with the integers, so solving for X here is really hard, since that's what we actually want. So solving here leads to division, which again is not closed in the integer, so that's a huge problem. Now, you can prove it using direct proof, and if you're interested in direct proof using this way, it's in the book. It's a weird, convoluted way to do it, but what we're going to say here is like, I don't want to deal with that. I'm just going to consider contrapositive. And a contrapositive proof, I will tend to err on these if the conclusion, so like use if the conclusion is the simpler part than the hypothesis. So what do I mean by simpler? Well, you look at it and it's got less stuff in it. The conclusion here is that X is odd versus this long piece for the hypothesis. So if I was going to write out the contrapositive, it would say if X is not odd, then 7X plus 9 is not even. So all I've done is I've reversed the order. So you see here, and I've added a negative to each statement, which makes it the contrapositive. So basically what you want to prove, so prove if X is not odd, means that if X is even, then 7X plus 9 is not even or is odd. And we can see here we've gone from a very sort of complicated statement to something that is hopefully very familiar from our previous lessons. So we will start out by saying, all right, say X is in the even numbers, which means that x is equal to 2a, where a is an integer. Since we're interested in 7x plus 9, we can use substitution to say that's 7 times 2a plus 9. Now we want to show it's odd, so I'm going to factor out a 2, 7a, and I want to show that we have an odd, so we have a plus 1. So I'm going to say this is 2 times 4 plus 1, which gives us 2 times 7a plus 4 plus 1. Now, 7a plus 4, we can say that's b, and that's going to be in the integers. And make sure that you reference closure in these cases, since the integers are closed for multiplication and addition, but not division, which is why we're having that problem in the direct proof. So then we can say that 7x plus 9 is equal to 2b plus 1, where again b is in the integers. So 7x plus 9 is odd. Now, since we've proven the contrapositive, so by proving the contrapositive, because the contrapositive is just that new statement. So the contrapositive is a statement just like any of the direct statements that we've come across so far. Then we can say, if we wanted to write it in symbolic notation, 7x plus 9 is an element of the even numbers, implies that x is an element of the odd numbers. Finish that up. So I'll scroll out so you can see the whole proof. Take a look at that. Pause if you need to write that down. So this is the method. So in this case, you're just going to be using the contrapositive. We will have some days when we return from Thanksgiving break where I give you a bunch and you have to determine whether contrapositive is the right method or whether the direct is the right method. For the next 2 days, you're just always going to be using the contrapositive, which means you can rewrite it in that format, complete your proof, and then finish it up with this new conclusion that's saying by proving the contrapositive or proof of the contrapositive, then the original statement in your box. Let me know if you have questions, and I'll be available by Zoom, email, or in the comments. Talk to you later.